The Mars 2020 mission is a mission of firsts. It was the first Mars mission to have a descent system capable of taking video during its landing process. It was the first Mars mission to be able to actually store samples of actual Martian rock, and it's going to be the first leg in an effort to return Martian material back to Earth. And while the Perseverance rover is an amazing advanced robotic achievement, my personal favorite part of the Mars 2020 mission is the Ingenuity Mars drone, which is the first aircraft to take a powered flight on another planet. And it is necessary to say powered flight because in the 1980s, the Venera missions to Venus deployed 2 weather balloons in the dense atmosphere of Venus that transmitted weather data for over 50 hours before melting. Now, balloon flight is very different from powered aerodynamic flight. Balloons fly by using gases inside of the actual balloon that are lighter than the surrounding air around it. That's why when you fill a helium balloon on Earth, it floats, because the helium inside the balloon is lighter than the oxygen and nitrogen mixture that is outside the balloon. Powered flight is a little bit more complicated, and powered flight on Mars is especially more complicated. Now, I know what you're probably saying. How can it be so different? All you have to do is just copy the design of a drone and then just fly it on Mars. In truth, it's much, much more complicated than that. It's not the 20-minute time delay between Earth and Mars that makes flying so complicated. We've figured that out. We have autonomous landing systems for rovers that we've been using for decades now to land rovers on Mars that way. And that's pretty much just what Spirit Airlines is, just automated, flying machines. The problem with flying on Mars is that Mars's atmosphere is 100 times thinner than Earth's atmosphere. That's a problem because helicopters and drones on Earth fly by generating lift. On helicopters and drones, the blades are curved on top to redirect airflow downwards. And if the blades spin fast enough, the redirected airflow actually causes an increase in air pressure underneath the blades. And that in turn is what generates lift and what pushes the helicopter or drone upwards. The problem with Mars is that there's less air to push you upwards. Earth's dense and thick atmosphere makes it easier to fly. But flying on Mars is the equivalent of trying to fly 100,000 feet off the surface of Earth. The record for a helicopter flying on Earth in altitude is 40,000 feet, and that was with a specially modified helicopter to generate more lift. So to compensate for these issues, the company that developed Ingenuity, AeroVironment, had to get creative with how they were designing the aircraft. Ingenuity had to have blades very large in proportion to the size of the vehicle to be able to push a larger amount of air downwards to actually push itself upwards. The vehicle also needs to have its blades spin very fast. The average helicopter or drone on Earth usually spins at around 500 rotations per minute, or RPM for short. Ingenuity has to spin its blades at 2,300 RPM in order to compensate for the lesser amount of air. The vehicle also has to be very light so that it can be able to push itself upwards. You also have to not spin your blades so fast that you break the speed of sound, because if you break the speed of sound with your blades, all it's going to do is create shock waves that will instantly destroy your aircraft. So in 2018, after considering all these problems, the engineers who designed Ingenuity took it for a test flight in a vacuum chamber. A vacuum chamber is basically just a room with most of the air sucked out of it. And after it successfully raised off the ground for about 10 seconds, NASA officially approved Ingenuity to fly on Mars. Since being deployed by the Perseverance rover onto the Martian surface in April of 2021, Ingenuity has gone on 43 successful flights as of the making of this video. NASA hopes to send more flying robotic missions to Mars so that when we actually do get around to sending humans to Mars, we can use drones to get samples from hard-to-reach locations or map out terrain from distances. So hopefully we'll be able to see these drones fluttering across the Martian skies pretty soon. So that's going to do it for this video, guys. If you liked this video and you want to see more of this type of content, consider subscribing to my channel. it motivates me to keep making this kind of content. But for now, that's all I have for you guys. And as always, stay curious.